Okay, this whole unit, or this pie slice, if you will, unit, is about triangles. And there's a couple things that you just really need to remember about triangles. I guess the main one, the huge one, is that if you have any triangle, angle 1 plus angle 2 plus angle 3, all add up to 180. Like, you just need to know that. That can't be something that you're like referencing. You need to memorize that. You just need to know that. It, it's going to come into play like over and over and over again. Excuse me. That and the fact from the last unit, which is that if you have two angles that add up to a line, like they want you to start recognizing lines, like this is a line. So this angle 1 plus this angle 2 is also equal to 180. You need to just start recognizing this. This line isn't on this page. However, it's going to come into play. Okay, it's going to come into play a lot. Okay, so all of the angles of the interior of a triangle add up to 180. A really fun activity is if you cut out any triangle from a piece of paper, if you construct a triangle using a ruler and like using a straight edge, you can cut off the corners and put them together and you will get 180. You will get a line. We may or may not do that as an activity, but it's pretty cool. In other words, if you ripped off this corner and you ripped off this corner and you ripped off this corner, when you line them up, you'd put like 1 here, 2 would go here, and 3 would go here, the little ripped pieces. And they make a line because they add up to 180. It's really cool. Try it. If you have some time, try it. All right. You can classify triangles, and it's one of the skills you're expected to learn. Classifying triangles by either their angles or their sides. Okay. So if you are classifying triangles by angles, okay, then they're either acute, obtuse, or right. Okay. Acute is a cute little one. Okay. That means this one's right because it's got a right angle. But acute means all of the angles are less than 90. Okay. So I'm going to use this as an example. This is a right triangle because it has a right angle. Any triangle with a right angle is a right triangle. It's that simple. Okay. If you need to write this down, write it down. Right triangle equals right angle, contains a right angle. Okay. This is acute. This is an acute because look, 60, 60, 60. So an acute triangle, all angles are less than 90. All right. The next one would be an obtuse. And that one is that there is one angle greater than 90. Now, how is it greater than 90? The other two can't be. They can't, if you think about this just for a minute, knowing that all the angles add up to 180, if we use more than 90 for one of the angles, the other two have to be acute angles. They have to be. So this is an obtuse. You can tell because it has that one angle that's bigger than 90. And this has a right angle. So it is, oh my God, the wind is so bad today. I don't know if you guys can hear it. That is right. I'm not going to do a second problem like this because I feel like this one you guys can get. And I don't need to give you your own problem to try just to get through these notes because there are 10 topics to get through. And the last ones are a little more difficult. All right, taking a look at this one. Oh, wait, let me lock this down again. Dang it, I keep forgetting to lock these down, lock them. Okay, this one says classify by side lengths. So acute, obtuse, and right are angle classifications. Side lengths are scaling, isosceles, and equilateral. The hardest one, well, I don't know which one's the hardest, but the easiest one, I think, is equilateral, because lateral means side and equa means equal. So this one means equal sides. So equilateral is this one right here. Do you see? Because it's got 11, 11, and 11. Okay. The next kind is isosceles. I feel like your middle school experience should help you with this. Isosceles means that this side and that side are congruent. Okay, that means they're the same size. This is isosceles. Look, it's got two sides that are congruent. So that is isosceles. And look at this one. Two sides are equal. That is isosceles. Now, what is a scalene? A scalene triangle is when all sides are different. This might be 5, this might be 8, and this might be 10. Okay, by the way, don't quote me on these. This is probably, well, I won't say it's right. Yeah, this will work. Okay, this is called a scalene. Scalene. All sides are different. Now, again, these are expected to be memorized, not referenced. Equilateral, isosceles, scalene. If you guys want to memorize them, say the words out loud to yourself as you do this. Say the word scalene, say the word isosceles, say the word equilateral. It will help you memorize. Connects like the language in your brain to what you're seeing, and you hear it say, so you're connecting like all the ways that you learn all at once. All right, so I did another one. Well, not another one, but this is where we go from here. This one is by side lengths or angles. So you have to decide. Look at the words. Scalene, isosceles, equilateral. That's by side lengths. Which one is this one? Look, 4, 7, 10. Nothing matches. It is scalene. Okay. Is it isosceles? No. Wait. Oh, by side lengths or angles. I thought they were going to mix them up with them. They didn't. They did. Yeah, this one's angles and this one's angles. Okay. See how they gave you angles and they're all the same? But look, they didn't give you the angle classifications of acute, obtuse, or right. Instead, they're asking you whether or not it's scalene, isosceles, or equilateral. So here's what you need to think about, okay? In fact, I recommend you look at the notes section of this, but if you have an equilateral triangle, okay, look at this mouth. Okay, all of these sides are equal. Therefore, all of the angles are equal. Do you see that? The mouths are open the same, okay, because everything is equal. So this is equilateral. Okay, take a look at this one. Now this is a theorem that you need to have down. Notice this. It gave you angles again, but they're asking you about side lengths. Okay, so look, these two match here. Okay, well, that means that this mouth, if you will, look at an angle as a mouth, like this is a little crocodile. Okay. Okay. I should draw my kitty since my kitty's always biting me, right? Okay, this is a little crocodile. This crocodile's mouth is open just the same. Okay. There. This crocodile's mouth is open the same, which means that the opposite sides are equal because they're opposite sides. Does that make sense? Their mouth is open, so the opening, when you're looking at an angle, okay, this is the measure of the angle. This is the measure of the opening right here. So it makes sense that if you have same angles, that you would have the same opening. Okay. So I want you to know this. If given, you should write this down. Isosceles triangle, base angles are congruent. That's the symbol for congruent, and it basically means equal. Okay, guys, means same size. And side, these sides, two sides, I can't remember what they call them, are equal, are congruent. So in other words, if you have an isosceles triangle where this angle is congruent to that, that's how we show that they're congruent. Then this one and that one are also congruent, this side and that side. So look, isosceles right there. And then look here, equal base angles are equal. I think what I want to say is that opposite sides, the opposite sides to the base angles, like see, these sides are congruent. Okay, we could call this the base, and these are the sides, which is why I said sides are congruent. All right, now comes the tedious part. Okay, I want to give you a hint. You get rewarded for watching these notes. Here's the thing. You need to be able to use the distance formula. It says determine, actually, let's go back here. Identifying coordinates to give right triangles. So what they're asking you, okay, they're giving you 3 coordinates, 1, 2, 3. And if you think about it, they're going to be graphed somewhere. You don't have to graph them, okay? But just, you could if you wanted to. So this would be 4, 5. Okay, 7, negative 10. Obviously, this isn't perfect. And negative 11, 2. Okay, so let's just say that this is it. What they're asking you is, is this a right triangle? Let's see if it straightens. It did. Yay. They're like, okay, that didn't work. I tried. Let's try again. Boom, come on. Yes. Okay, it's basically asking, is this right? Is this angle right here a right angle? Now, how the heck would you even know? Okay, what do you think they want you to do? This is actually kind of tough, right? So you're going to be looking at this, and I really want you guys to focus in on this one, okay? This is negative 11, 2. This is 4, 5, and this is 7, negative 10. Okay, what do we know about perpendicular lines? Okay, now you see geometry is all about what you know, what you knew before this day, and how you can apply it to the future. What do we know about perpendicular lines? Here's what you need to remember that we just studied. Perpendicular lines have slopes that are negative reciprocals. Okay, so in other words, if the slope of line 1 is equal to A over B, the slope of line 2 is equal to negative B over A. Okay, we need to use that information now. So this is a pretty tedious problem, and it'll most likely end up being one of the last problems you do just because you don't want to do it. I encourage you to connect it or like do it with the first 10 only because a lot of the other ones are easy and this one is super tedious. So you need to figure out the slope of this line, okay? So the way you're thinking about this is we figure out this slope and we figure out this slope. And if they're negative reciprocals of each other, then ding, we have a right triangle, okay? There are other ways to determine whether this is a right triangle. We could find the lengths of all the sides and then use the Pythagorean theorem. but that's even longer than doing it this way. So I'm going to find the slope of, I didn't name these. This is J, this is L, and this is K. Okay, it might help you to actually graph these, like just sketch it out. Okay, so the slope of LJ is equal to, okay, I'm going to call this x1, y1, x2, y2. So 5 minus 2 over 4 minus negative 11. That's 3 over 15, or 1/5. Okay, so the slope of this line is 1/5. What's the slope of this line? Okay, so let's do the slope of this line now. M of JK. I should have put this. Okay, equals. Okay, since this is x2, y2, I'm going to call this one, well, I'm just going to take it, negative 10 minus 5. It's the difference in the y's over the difference in the x's, right? So negative 10 minus 5 over 7 minus 4. This is negative 15 over 3, which is negative 5. Check it out. 5 is 5 over 1. 1/5 and negative. These two are. This is a right triangle. Okay. Now look, for all of that, I answered one question. Okay, so you can imagine you have 9 of these to do. So you want to be super careful when you do them. Okay. You definitely want to sketch out these points. Like when I look at this one, t is negative 5/4. I might want to just do like a quick little thing like this, like 1, 2, 1, 2, 4. Okay, this is t, negative 5/4. This is what you probably should do for each one of these problems. 1, 2, because you don't know which angles are the right angles or what might possibly be the right angle until you see it on a graph. Negative 9, oh wow, 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 9, 0. Okay, so this is negative 9, 0. Okay, so I didn't draw this well, but you can tell which angles these two lines might be right. You could figure out the slopes between all of these and figure out if you have a situation like this. I think it's easier to sketch it because it leaves you only 2 to do. You don't have to do like a bunch of slopes. So I'm going to figure out the slope between, this is I. Okay, I'm going to figure out the slope of IT. It. Okay, I'm going to take the difference in the x's. I'll do I first, since I named it first. Why not? 0 minus 4 over negative 9 minus negative 5. Negative 4 over negative 4 equals positive 1. Now, let's try doing the slope of TR. This is R. Okay, what's the slope of TR? Okay, since I put T first, I'll use that as my x1, y1. 4 minus 2 over negative 5 minus 1. You'll notice I'm not teaching slope anymore. It's assumed that you know it. Negative 6. This is negative 1/3. These are not. Okay, so I would say it is not a right triangle. Okay. It's funny that they have cannot be determined. I'm trying to figure out how could you not be able to determine it? I'm not sure. Let me know. You guys might have to let me know on that one. All right, and then you guys could do the third one, but do you see this is kind of like, it's a long problem. There's a couple really long problems in this section, and it's best to just maybe tackle them in class, maybe when you have to be there and you have to focus. All right, this one says we're identifying by their side lengths, you guys, by their side lengths. So now, okay, we are now going to be using the distance formula because we need to figure out how long these sides are. So again, I actually don't think you need to draw this triangle, but it doesn't hurt. I'm a very visual person. So for me, it's really helpful to draw it. So that's P. That's Q, -5, 4. Okay, and then you would do the last one, 5, -5, -3. Probably about there, 2, 3. Okay, sorry. All right, and then it wants you to classify whether or not it is scalene, isosceles, or equilateral. Well, think about this. A scalene has all different side lengths. An isosceles has two side lengths that are the same. So if you do the distance formula and you get two sides the same, you can stop right there. Okay? Equilateral means you have to get all three, and scalene means you have to get all three. Okay? The only one you could stop at would be isosceles. And no, you can't even stop at isosceles because you have to go all three to figure out if it's equilateral. Sorry. All right, so this is really tedious. You're going to have to use the distance formula, but I'm going to give you a nice little trick as a reward for watching notes, okay? Distance formula, PQ. So what I'm doing is I'm going to find the distance between P and Q. Then I'm going to, that's right here, okay? Then I'm going to find the distance between P and R. I can actually count the distance on Q and R since it's a vertical line. That's where the graphing comes in handy. That distance is from -3, so I go up 1, 2, 3, and then I go up another 4. So this is 7, okay? This length is 7. I just counted it in the graph. Okay, so all I need are two distance formulas, PQ, and I need to find PR, okay? PR. Okay, PQ, we're going to go. Okay, remember, distance formula is D equals, and I recommend you write the distance formula until you memorize it. Actually, recommend you write it all the time. What am I talking about? Formula, substitution, resolution. It really does help. It's the difference in the x's squared plus the difference in the y squared. So difference in the x's, 0 minus -5 quantity squared plus 1 minus 4 quantity squared equals 5 squared. I took it out of the parentheses because this is +5 squared plus -3 squared. I didn't take it out of parentheses because it's negative. 5 times 5 is 25. -3 times -3 is +9. I'm going to have to move this little guy here. Okay, so this is the square root of 34. And you can leave it like that. Just leave it as the square root of 34. That's all you need. Okay, I'm going to go ahead and erase the distance formula. You should have that down by now. Okay, if you're having trouble with the distance formula, write the dang formula. Okay, so let's do, now we're going to do PR. PR. So PR rather, is equal to the square root of, okay, and I'm going to show you this first. I'm going to do it with the distance formula first. 0 minus -5 squared plus, now the difference in the y's, 1 minus -3 squared. You might be able to tell that they're going to be different. Look, that's going to be 5 squared, and that's going to be 4 squared. 1 plus 3 equals 4, 4 squared. This is equal to 25 plus 16, which is the square root of 41. Are these triangle, is this, what kind of triangle is this, I should say? So PR, this length, was the square root of 41. This length was the square root of, stop that. Whoa. Now I can't get it to select that. Let me go back. Sorry. Did I move that P? I think I did. 0, 1. Nah, I didn't move that much. I'm good. Okay, but you get the idea. This is 41. Sorry. So this is the length of one side, this is the length of the other, and this is the length of the third. This is a scalene triangle. See how obnoxious that is? I do want to show you that because you're watching these notes, I'm going to give you a little hint. If you go on Google, okay, because once you know your distance formula, you're going to have to know it. I would say do it until you get good at it. And don't do what I'm going to show you until you are good at it. Once you're good at it, you can do this. Distance formula calculator. There you go, boom. Ready? Look at what you get. Okay, Distant Math Warehouse. Check out this one. There's lots of them, but here's what you get. You get a calculator. All you have to do is enter your points. Yo, where did that go? Stop that. Why are you doing that? Maybe Math Warehouse sucks. Maybe I don't want to do Math Warehouse. Whoa. Okay, I'm not exactly happy with Math Warehouse because it's giving me all kinds of things I have to dodge. I can't stand websites like this. Okay, well, let me do this. Is it because I'm on? Here, let me try this again. Okay, let me try again. Distance, formula calculator in my search. Boom. All right, calculator soup, Omni calculator. I don't know. I guess I could do this. Okay, yeah, here you go, right here. So you could just enter the points. So if you're looking on this example, okay, what I would do, let's say you're trying to do this TRI one, okay? I'm going to go ahead and erase this. Here's what I would do, just to speed up this process for those of you that can already do the distance formula. Honestly, if you can't do the distance formula, you need to practice. It is an important formula to know how to be able to manipulate. Okay, once you do, ready? Let's just quick sketch this out. 6, 5, 1, 2. I mean, you don't have to do this technically. It just, for me, I like to. This is T, 6, 5, negative 2, 5. See, that one's easy. See, this length is easy. You can just count it. You went 1, 2 plus 5. This one is 7. Okay, 7. All right, and then R is negative 2. Wait, no. This is R. I is 2, 0. So the 2 points that the 2 side lengths we need are this side and that side. Okay. Some of you might be able to tell that this is or isn't just by counting that this. Check out this triangle right here. It is 1, 2, 3, 4 by 5, and look, this is 1, 2, 3, 4 by 5. You can tell that those sides are going to be equal. Let's pretend you. I shouldn't say pretend. Maybe you didn't. Okay. So you got this idea. Now we need RI and we need IT in order to know what these side lengths are. Okay, so let's go to our calculator. R is negative 2, 5, and I is 2, 0. So you go negative 2, comma 5, and 2, 0, right? Ready? 2, 0, and then you just hit calculate. Boom. Now where is it? Okay. Here we go. It's actually doing the problem for you, and you get the square root of 41. Okay. So we know that this one is the square root of 41. Okay. Now we want, that was TI. That was TI. Now we want this one, negative 2. Wait, that's the one I just did. Duh. Okay, sorry. I need to do this one, which is 6, 5, and 2, 0. Okay, let's try that. I'm going to leave 2, 0 there. And I'm just going to write 6, 5. 6, 5. Okay, here we go. Square root of 41. There it is. Okay. So this is also the square root of 41. Now we have an isosceles triangle. So I'll let you go ahead and use that calculator, but not on a test. That's why you need to practice it until you're good at it, okay? You could even practice it and then check it with that distance formula calculator, okay? For those of you that are still struggling with that little piece of it. All right, next. This is, now this is what I think is the funnest part. It's when you have to find the missing angle. It's kind of like, it feels like a game sometimes. Now this is pretty easy in that they gave you two angles. You just have to find the third. This is where you need to know that all of the angles add up to 180. So all you do is basically 180 minus 111 plus 33. You need to put it in parentheses, by the way, or some people might also think of it as this way: 180 minus 111 minus 33. It's the same. These two are the same, because if you were to distribute this negative, you would have that. But most of us like to add this up first. These two angles together add up to 144. They give you numbers that are easy to do in your head. You guys, 3 plus 1 is 4, 3 plus 1 is 4, 144. 180 minus 144 is 36. So 36 is your angle. Now you can just get in a calculator and do this: 180 minus 111 minus 33, and you'll get 36. All right? You don't have to do it by hand. And that's the simplest one. I'm not going to do a second one because that one's pretty easy. We're going to be using it in the next one. Okay. So remember I told you about the whole line thing? Look, you guys, do you see the line? That means you can figure out what this angle is. It's going to be 180 minus 135, because these two angles add up to 180. 180 minus 135. That is equal to, again, I don't care if you use calculators, 45. So this is a 45. That does not look like a 45. Did I do that right? Oh no, that's 45. Hello. Shoo, jeez. Okay. This is 45 right here. Okay, now we have this angle. If we have this angle and we have this angle, we can now find that angle, because we know that all of the angles add up to 180. And the goal here was to find x. I actually should read these instructions. I'm sorry. Find the value of x. Okay, so I just start doing this stuff because it's kind of fun. I'm like, oh, I could figure out that from there. Okay, so 45 plus 51 is equal to 5 plus 1 is 6. Add your ones, add your tens. 96. Subtract from 180, and you get 4. 17 minus 9 is 8. 84 degrees. Okay. I don't think I did another one of these because, again, those are the ones that are a little bit more simple. Now you get to the more complicated ones. Again, in geometry, it feels very much like a game of dominoes. You just need to look at what they gave you, and then you tip that one over, and then that'll start the next one, and it'll just keep doing that. So when you look here, I'm not sure, by the way, when this popped up on my screen, the only thing it said was find x. There was no picture. So this is actually the first picture of the explanation that I had to copy. I'm pretty sure they gave us 48 right here, but not here. So we had, the first step was figuring out this angle. Okay, when you're doing these problems, don't forget, vertical angles are congruent. This is going to come into play so many times, you might as well just get used to it. Vertical angles are congruent. So look, these are vertical angles. That means they're congruent. So we figured out 48. Woo! Yay. That was the first angle. Okay. What are they asking for? They're asking for x. Well, we can't figure out x until we get all three, get the other two angles. Well, we got one, but we need the other one. See the line? You see this line? This 91 plus this angle is equal to 180. So all you do is take 180 minus 91, which is 89. So now we know this one is 89. So now we can figure out x, because we know all three angles add up to 180. Okay. I like to, you know what, actually, if I had a calculator, I would just do 180 minus 48 minus 89, honestly. Because I don't work with a calculator when I'm doing notes, just because I tend to do everything by hand. But you guys are welcome to just grab a calculator. I'm faster by hand than I am with a calculator, so it's fine. Okay. And you get x is equal to 43. I think I should, unless I made a mistake. Should be good. All right. Here's another example. Now they're giving you parallel lines. Okay. Parallel lines. And they want you to find x. So you have to look at this picture and you have to ask yourself, what can I figure out? Well, all these three add up to a line, but I don't have that angle either. Well, that's not helpful, right? You have to go back to your parallel line information. Do you guys see this? I'm going to show you something you might not notice. These are two parallel lines. Guess what this is? This right here, this line right here. Oh my God, I'm so sorry. I cannot draw on this thing. This line is a transversal. I think it's because of my hair. Let me see if I can try. Let me try to do that again. I'm sorry. It's so ugly. I can't handle it. Let's try this again. This is a transversal cutting through two parallel lines. Okay, do you see it now? So we have 113, which is one of the interior angles, right? What is 113 congruent to? Well, it's congruent to here, correct? Because corresponding angles are congruent. It's also congruent to this whole thing, right? These two angles are alternate interior. There's a couple different ways you could do this, but either way you look at it, it's going to end up being this situation. That you have 113, do you see it, is equal to this. And what is this angle? Well, walk, pretend you're in the picture and walk on this. And how far did I walk? How many degrees? 33. And then how far did I walk here? X. That angle is 33 plus X. That's how we write it. Okay. And that's equal to 113. Now you have an algebra equation to solve. You just subtract 33 and you get, I'm going to do this. I'm going to show my work. So I need to actually show my work correctly, guys. 3 minus 3 is 0. 11 minus 3 is 8. 80. So X is equal to 80 degrees. But to do this, you had to realize that this was a transversal. Okay. Next. By the way, there's more than one way to get here. Some of you guys might have gone this route. You might have been like 113. Vertical angles are congruent. These two are vertical angles. See it? Might have done it that way. It still would have given you this equation, but you might have looked at it differently. Some of you guys might have said this is equal to 113 because it's a vertical angle, and then these are corresponding angles. Still gives you the same equation. All right, take a look. Here's another one. Now we want X again. We're always finding X, right? Okay, so can you find the transversal that's important here? Okay. Do you see what we have? We have 3380, okay? But we also have a line here. You see it? There's a lot of different ways to get here, and I can't tell you what your brain is going to go to. Okay, you can see that X plus these two angles, if you remember, consecutive interior angles equals 180. That means 33. What is this angle? This angle is 33 plus 80. That is 113. Yeah, that's right, 113. All right. So if this angle is 113, you would go 113 plus X equals 180. So x is equal to 180 minus 113. I'm going to get rid of that little x there. Oh, I forgot to nail this down again. Dang it, anyhow. Okay, so x is equal to, sorry, that doesn't belong there. 7, 10 minus 3 is 7. 17 minus 11 is 6. Okay, 67 degrees. Now, you guys might not have realized that. Truthfully, that probably wouldn't be my first way to do it. I probably would have found this angle first by subtracting from 180. I would have been like, what's this one? And I would have done 180 minus 67, and I would have gotten 113. Oh, wait, I didn't have 67. I'm sorry. I'm a dork. I didn't have 67, y'all. Oops. Don't do that. Don't do that. I have to lock this down. Dang it, anyhow. I keep forgetting to lock it down, and then I have to keep all my work. Okay. No, I probably wouldn't have done that. I probably would have been like, this is 113, because these are alternate interior angles. And then I would have had the same equation. Okay, 113 plus x equals 180, because 113 plus x equals a line. That's how I would have done it. There are so many different ways to do it. Just depends on how you analyze your parallel lines. Remember, when they give you parallel lines cut by transversal, you have all of those, the one that I made you make a picture of, right, that I had you color. Those are really important. I think this is the last one. Yep, this is the last one. All right, last topic for today. Now they're giving you a triangle, okay? And they want you to find the angle measures given a triangle with given angles with variables. All right. Well, here they gave you a right triangle. Okay, and they want you to find x. Well, you need to know something special about right triangles. Okay, in a right triangle, okay, right triangle means it has one angle. One angle is equal to 90. Okay, well, guess what? If this angle equals 90, right, then what do the other two angles have to add up to? They have to add up to 90, because 180 minus 90 is 90. In other words, angle 1, angle 2 equals 90. In a right triangle only. In a right triangle only, because 90, if you take away this 90 from the 180 that they add up to, the other two must add up to 90. So we use that here. Okay, we're going to use that property right there, and we're going to say 4x minus 16 plus 2x plus 22 equals 90. I mean, you could add 190 and say it equals, add this 90 and say it equals 180, but that doesn't make any sense. But you could. It makes sense. It's just more work, I should say. It definitely makes sense. Combine like terms. Plus 22 minus 16. 16 plus what is 22? 4 plus 2, 6. Equals 90. Subtract 6 and you'll get 84. And then you divide by 6. 6 goes into 8 once. There's 2 left over. 6 goes into 24. 4 times 14. X is equal to 14. Is that what they asked you to do? Okay. It isn't what they asked you. They didn't want X. Do you see that? Here's the directions. Find the degree measure of each angle. That means you have to take your X and you have to plug it back in to these equations. So it's 4 times 14 minus 16, and 2 times 14 plus 22. Again, you could just be there with your calculator and just do this. 4 times 14, is that 64? No, 4 times 16 is 64. 4 times 4 is 16, 56. 56 minus 16 is 40. Okay, so that would have been 40 degrees. Again, just do it in your calculator if you don't feel like doing it by hand like I'm doing. This is 28 plus 22 is equal to 50. Okay. And look, see? They add up to 90. Pretty cool. But the next one. Okay. Pause it and try it if you need to or want to. Take a look. We don't have a right triangle this time. Okay, so in the triangle below, basically when they give you directions like this, they're just telling you what the picture says. Okay, here's the directions. Find the degree measure of each angle. Okay, so we got to find x in order to find this. What do we know about all three angles? They add up to 180. Okay, 1, 2, 3, 5, 8x. We have 8 x's all together because we have 1 plus 2 plus 5. And then negative 3, and negative 1 is negative 4. We add 4 to both sides. And then x is equal to, divide by 8. 8 goes into 18 twice. Ooh. In this case, look, we're not getting an even answer. We're getting a decimal. By the way, decimals are okay with angles. We don't use fractions, we use decimals, okay? So 184 divided by 8. Again, if you guys are doing it in your, I'm so stupid. Okay, I'm not so stupid. I found out a mistake. I was thinking that was 9 for some reason. I don't know why. 24, it equals 8 goes into 23. That's it. It didn't equal decimals. X is 23. So you come back and you substitute it in. This is 23. So angle X equals 23. This is 2 times 23 minus 3. So that's 46 minus 3 is 43. This is 43. Okay, if you will. This is 5 times 23 minus 1. 5 times 23, I don't know what that is. 115, 114. And if you wanted to check it, like say you just wanted to make sure you were good, especially on a test or something, add them all together and see if they equal 180. That's 10, 6 plus 4 is 10, carry the 1. 10, carry the 1. I got 280. Wait, what did I do wrong? Oh, I don't care. That's not 1, that's not 10, that's 8. Sorry, people. That's 8. 180. All of these add up to 180. All right, I think that's it for notes.